So in the last class, where did I stop up to? I think it's up to Maxwell's reciprocal theorem, right? Can anyone please confirm? Hello.
Yes, sir.
Yeah, so in the last class, like I took up to Maxwell's reciprocal theorem. So what I will do is like I will start again with Maxwell's reciprocal theorem. We will do one small problem based on that, and then we will proceed to moment area method, and then we will see strain energy and Castigliano's theorem. Okay.
सर आज तो आरएससी का क्लास होता है ना?
No, no. Today is like class on SOM. So tomorrow, SD will be handling like RAC.
ओके.
Yeah. Today only 6 members have joined. Okay. So shall we start the class then? I'm starting the class. Okay.
यस सर.
Is my screen visible?
यस सर.
Okay. Thank you. So this is week number 9. Okay. So we are going to see the part 2 of the deflection of beams. So in today's class, we will see about recap of Maxwell's reciprocal theorem, and then we will see about moment area method, and then we will see some concepts on strain energy, and then we will go to Castigliano's theorem. Okay. So actually, in Maxwell's reciprocal theorem, can anyone say what is Maxwell's reciprocal theorem?
If at a point load is applied and some deflection is there at another point,
Okay.
if the conditions are reversed, for example,
Yeah. Okay.
जहाँ पे हमें डिफ्लेक्शन दिया हुआ है वहाँ पे लोड लगाएं और उस लोकेशन पे जहाँ पे डिफ्लेक्शन के बारे में पूछें तो वो मतलब सेम
होता है. Okay, I'm very sorry. Actually, I don't know Hindi. Okay, so pardon me. I'm very sorry. Okay. So if you can translate it in English, then I think it would be very good.
If at a point force is applied and another at another location, some deflection of the beam is given, then if the condition like at that point where the displacement or the deflection was given, if the load is applied at that location, then मतलब कि अगर जहाँ पे पहले the location where previously load was applied, same deflection will be there.
Yes. So what we have seen is like, for example, let us take this as point B, okay, and this as point A, and I'm applying a load which is WA, okay. Let us denote this load by WA at point A, okay, and then the deflection at this point is taken as YB equals, YB equals to YBA. Here YBA implies like load is acting at point A and the deflection is at point B. Okay. And here this I am having the same beam. Okay. And here I am having the point A and point B. Okay. And here the load is applied at point B. And then I am taking the deflection at point A due to load applied at point B. Okay. And this will be YAB, which is equals to YA. Okay. If this is the case, then what I can write for the same beam, okay, WA into YAB, okay, this load into this deflection, which is equals to WB into YBA, okay, and this is called Maxwell's reciprocal theorem. Similar way, like I have denoted it for like moment also, right? Last time. Everybody remember that moment also, right?
Yes, sir.
Yeah, thank you. So again, for same thing, I'm actually saying for the moment, okay, this is point A, let's imagine. And then if I'm having a moment like this, for moment, what will be the relation? I mean, whether it is connected with deflection or it is connected with slope.
Slope.
Yeah.
Slope.
Yeah. So this is again point A, point B. Now here I am applying a moment, and let's say this has MA and this has MB. And then for this, again there is a deflection, right? So here what I can write is like MA into theta AB. Okay, here only I will get, I mean, a moment applied at B, okay, and slope at A, okay, which is here, okay, which is equals to moment applied at B into slope, I mean BA. Okay, this is called Maxwell's reciprocal theorem. So based on this, we will do one small problem, okay. So I am having a simply supported beam here. And then I am having a load here, W by 3 at a distance of L by 4. And here is point B, which is at a distance of L by 4. And here it should be L by 4, L by 4, okay, L by 4. This is also L by 4, okay.
Sir, once again, previous
slide, okay.
Okay.
Okay. And this length is also L by 4, okay. And then I'm having a similar beam. And then here is, this is point A, okay. And here is point A, which is at a distance of L by 4. And here I have another one load, which is W by 4. And this is L by 4, this is B, and this is L by 4. And the deflection here, okay, YB, let's say, which is equals to YBA. YBA means what? Like, what is the deflection at point B due to load applied at point A, okay, which is equals to delta. So can you find out what is YA, which is like the deflection at point A due to load applied at point B? Can you find this and say? I need YAB in terms of delta, okay? Simple.
3 by 4 of delta.
3 by 4 of delta, yes. So what you have applied is like, according to Maxwell's reciprocal theorem, it is WA into YAB, which is like load acting at, deflection of point A due to load acting at point B, which is equals to WEB into deflection of point B due to load acting at point A, okay? So if we apply this, then what is the load acting at point A, which is W by 3, right? and what is the deflection YAB? That is the thing we have to find. Okay, and WB is actually W by 4, and WBA is delta. And if you do this, YAB will be something 3 by 4 into delta. Okay. Up to this, it is fine.
Yes.
Yeah. So can we now? We will discuss about moment area method. Okay. This is very important method for calculating the deflection of beams. Okay. And this method is used for. It is very useful for cantilever beam and symmetrical loading with simply supported beam. Okay. Very useful for cantilever beam
Sir,
yes.
this is second method, no?
This is see, till now we have actually discussed based on the formulae only. Okay, with simple formulae and with simple logic, how can we actually find out the deflection of beams? Okay, but today only we are actually seeing a specialized method for calculating the deflection of beams. Okay, if there is no standard formula which is available by which we can actually calculate the deflection of beam at say any particular cross section. Okay.
Means this is general.
This is in general, but this is very useful only when you want to calculate deflection for cantilever beams and symmetrical loading for simply supported beams. Okay.
Okay, sir.
Yeah, means what I'm saying is like, for example, for these things, ready-made formulas are available, right? For example, you are having a simply supported beam which is loaded at its middle. And for this, you are having. I have actually shared the formula sheet, right?
Yes, sir. W cube by 48.
Yes, yes. So for those things, you can directly apply the formula, or like with a simple manipulation of the given loadings, you can easily apply. For example, if you have a look at this thing.
Sir, main issue, sir,
Yeah.
I faced issues regarding the composite beam where EI varies.
Okay. See, for EI varies, this method is actually very useful. Moment area method is useful. Let us see all those things. Okay.
Okay.
Yeah. So for this beam, what you will do to calculate the deflection of this beam, you can replace it like with an equivalent system. Like say, for example, like I will have a deflection like this. Okay. And then no. Actually, this can be replaced by an equivalent system, which is like, if I want to calculate the deflection at say this point, okay, point B, and what I will do is like I will split this into a system which is consisting of two beams like this. Okay. Okay, and for this you can easily find out the deflection of beam at this point, right?
Here, first figure also split into two parts.
Yeah. 1 minute.
Sir, splitting थोड़ी ambiguous लग रही है.
No, actually, I want to mention something else. And since I'm at my home and I'm also not having my notes, I couldn't able to see this. What example I could give you? See, actually, what I meant here is like with basic logic, we can actually like we have decomposed all these things, right? In the last lecture, if we have seen, yeah, here it will be clear, I think so. Here and all, how we have actually figured the deflection of beams, like we are actually splitting each things, right, in terms of its individual relationship, where we actually explicitly know the value of the deflection of beams due to a single point load. Okay, based on those things you can easily find out the deflection of beams for these kinds of complicated cases. Okay, but whereas, for example, if I have a beam and in my beam, whereas I cannot easily find out the what to say the things easily, then at that condition I have to go for these things. Okay. What I'm saying, are you getting?
Yes, sir.
Yeah, that means complicated. We are going this method.
Yeah, maybe in the next class I will try to explain it very in detail. Okay, after when you see this moment area method, you will get to know why we are actually going for it. Okay, in the last class also I took more time, and then actually I couldn't complete some 2-3 problems wherein like we could have done the things differently for different beams. Okay, maybe I will try to cover up those things in the next class. Okay. So
Okay.
In today's class we will see about this moment area method, and then you will get to know why we are actually going for all these things. So shall I proceed?
Yes, sir.
Yeah. I couldn't able to remember actually my note. I'm not having my notes with me, so sorry for that. Okay. So in this moment area method, what we are actually, I will tell the basic procedure. Okay, with a problem. Okay. See, for example, I'm having a cantilever beam like this, and then I need to find out what is the deflection and slope at point B, okay, due to this load W. Okay, for example, what is theta B and what is YB. So what should I do is like in this moment area method, let us name this as point A. Okay, in this moment area method, first we have to actually draw the bending moment diagram first. Okay, and then we have to draw the M by EI diagram. Okay, so can you please draw the bending moment diagram for this, and can you say whether it's positive or negative, and whether its shape is like a triangle or a rectangle?
Triangle, sir.
Triangle, okay. And whether it's negative or positive?
Seems like positive.
Sure.
Negative, sir.
Yeah, negative, because it's right. See, for example, if I take any section and when I take the right, it is clockwise, right? So it's negative. Okay.
And if we consider reaction at point A,
Okay.
then
See, for example, this causes a reaction in this direction, right? W into this length, say L, and here I am having a moment.
opposite directions.
Yeah. WL is in the WL is in the, for example, W into L, yeah, it is in this direction, right? Moment. W into L. So what is this direction actually? It is left anti-clockwise, right?
Yes.
So left anti-clockwise means it's negative.
Negative.
Yeah. Okay.
And here reaction at point A will be vertical, and it will give positive, and then this negative term will go on decreasing.
Yes. Yeah. Due to this, for example, this W, okay, this will give a positive reaction. I mean, positive bending moment value all through this section when we are actually proceeding from 0 to L.
Yes.
Okay. Yeah. So first we have drawn the bending moment diagram. Okay, and then we have to draw this M by EI diagram. Okay, this is of constant Young's modulus and constant moment of inertia beam. Okay, so when we draw the M by EI diagram, it will be the same. Okay, only thing is like I have to divide this moment by EI. Okay, this is M by EI diagram. For example, if I have a changing value of EI, someone has asked this question, right? What shall I do when I have a different value of EI? So at that moment, for example, where the cross section whose EI value changes, there I have to take another M by EI value and then I have to plot it accordingly. Okay, we will see those problems also in today's class. You will get to know during that time. Okay, so this is also negative. So in order to calculate the slope, first what I should do is like, where you have to determine the slope or the deflection, it is at point B, right? Okay, so point B you have to take as the origin, where you have to determine the slope and deflection. Okay, that point you have to take as the origin, and you have to take a reference point also, and the point where the slope or deflection is 0, that point you have to take as the reference point. So 2 points you have to take. One is the origin point and another one is the reference point. This origin point is where y is to be determined, or tau or theta is to be determined. Okay, whereas this reference point is where theta or y is 0. Okay, so for this case, which is the origin point? B is the origin point and A is the reference point. Okay, so here how can I calculate theta? I mean theta B is like,
both should be 0 or
no, see, origin point is where y, no, like for example, both should be 0 means, if I am calculating both the slope and the deflection, then I can take both, I mean point A as the reference point. Here you can see like at point A, both deflection as well as slope value is 0. So here you can take the reference point as point A itself. For example, you want to calculate only the deflection, and you know at some point, for example, simply supported beam is there, right? Okay, simply here y is actually 0, whereas theta is not equal to 0 at this point. I'm saying, maybe let's name this point as point D. So here in this case, I want to calculate only the deflection value. Then I can take like this as the reference point C as the reference point. But if I want to calculate the slope at a point, I mean, for example, at point B, I want to calculate the slope. Okay, then I can't take point B as the reference point, because I mean point C as the reference point, because like theta, if I put theta B minus theta C, then theta C is actually unknown. Then I can't find out what is actually theta B.
Okay, sir. Means
Yeah.
to eliminate, we are taking it as
Yeah,
0.
just to eliminate the for example, in the formula, if I'm writing now, theta B minus theta A is actually area of M by EI diagram. Okay, just in order to eliminate this theta A equal to, I mean, just in order to put this theta A equal to 0, I'm actually using reference point as where theta or y is actually 0. Getting what I'm saying?
Yes.
Yeah. So theta B minus theta A is actually nothing but area of M by EI diagram. Okay. And similarly, YB minus YA is nothing but first moment of inertia of M by EI diagram, which is nothing but AX bar of M by EI diagram. Okay, and here for this case theta A becomes 0, and for this case YA becomes 0. So directly you can find out what is theta B and what is YB. Understood?
Yes, sir.
Yeah. So can you find out what will be the value of theta B first, and then let's go for AX bar. This is area of M by EI diagram. Yes. Hello.
WL square by 2EI.
WL square by 2EI. Yes. That's the correct answer. And the direction you have to specify it, right? Which direction? Whether it's clockwise direction or anti-clockwise direction. Slope.
Clockwise.
Yes. So with sign convention, you can write it here. Okay. So for this example, theta B minus 0 equals to area of M by EI diagram. Okay. between B and A. So if I write what will be the area of this, it's a rectangle, right? So I have to write, and it's also in the negative direction. Okay, here only the sign convention actually comes into play. Okay, so I have to write with the sign, and the negative sign indicates like the slope is a clockwise slope. Okay, the slope direction is in the clockwise direction. So it will be minus 1 by 2 into WL by EI into L. So it will be minus WL square divided by 2EI. Or when I write the direction, it will be WL square by 2EI, and that direction is clockwise. Is this clear? Okay.
Yes, sir.
Yeah. So with respect to YB minus YA, can you write what is YB minus YA is actually 0, okay, which is equals to AX bar of M by EI diagram. See, for this thing, you have to calculate the moment of area, okay. So how you can actually calculate the moment of area of this M by EI diagram?
Area into its centroid.
Centroid, yeah. So can you find out the see at this is point A, and I mean this is point B and this is point A, okay. So you have taken point B as the origin, right? So any centroid you have to calculate from this point B, okay. The distance of the centroid should be calculated from this point B. X bar should be in this direction, okay. So what will be X bar here?
2L by 3.
Yes. So the area already we have calculated, it is negative, okay. Minus 1 by 2 into WL by EI into L, okay. And this is the area, and X bar is actually 2L by 3. And if you write, simplify, what is the value?
WLQ by 3H.
Yes. And it will be negative. Negative means downward direction, okay. And if I write the direction, then it will be WL cube divided by 3EI, downward direction. So this is a very simple problem. So just in order to understand what is moment area method, we have done this, okay. So the basic procedure is clear, right? How we are actually doing the procedure for moment area method. Now we will start solving some more problems so that like you will get used to how to solve by using moment area method, okay. So here is a cantilever beam, okay, which is loaded at the end like this. This is point B and this is point A. You have to find out what is theta B and YB, okay. Theta B equals to question mark and YB equals to question mark. So this can be solved by any other method. Anyone can think of a method by which we can actually solve this. What is the value of theta B and YB?
YB वाले के लिए sir Maxwell we can use.
Okay.
But
Yeah.
here we don't have two loads.
Yeah, what you can do is like you can actually see, for example, if you are using Maxwell's theorem, then you have to consider another one beam, and then you have to find out what is the deflection here at YC when load is acting at point B. Something like that you have to do. So this we have seen, right, in the previous class. For example, if the load is acting at point B and you have to find out, you have to find out the deflection at point C. This we have done, right?
Yes, sir.
Yeah. So similarly, here I have to do. So it will be something like this. So the deflection curve will be like this. So the calculation actually becomes very larger, okay, because like you have to first find out what is the deflection at yb, and then you have to find out tan theta, then you have to find out theta, then you have to do all the slope calculation, and then you have to find out what is the value of yc, okay. But if you use the moment area method, it will be much simpler in this case, okay.
Yes.
Yeah. So can you use the moment area method and tell me what is the value of theta b and yb? First,
What is the
yeah,
location of point?
location of, okay. So location of point is L by 2 from the fixed end of the cantilever beam. Okay. So this is L by 2 and this is L by 2. Can you draw the bending moment diagram?
Yes, sir.
Yeah. And what is its shape? You can say to me.
Positive triangle.
Positive triangle, yes. And this will be WL, right? This triangle is positive. And this is point C. And where you want to find out the deflection, you have to find out the deflection here or the slope here. Let's name this as point A. So which is the origin point you will take?
B.
B.
Yeah, B is origin. And what is the reference point here?
A.
A. Yes. So how you will actually find out theta B? Theta B
Area
minus, yeah, area of M by EI diagram. So if I draw the M by EI diagram, it will again look like a triangle with the far end value will be WL by EI. Okay, this is point B, this is point A, this will be WL by EI. M by EI diagram. And here I have to find out what will be the slope and deflection. So how can I find out this area? Can anyone say what is the value of this area?
3 by 8 W.
Yeah, correct only. So here, since 1 by EI is constant, or let's say like I will put A1 plus A2, okay. For example, I will name this as A1, okay, and this as A2. So area of A1 plus A2 will give me theta B minus theta A, okay. So if I want to find out what is A2, it will be WL by 2 into EI, okay, into L by 2. If I do any mistake in calculation, you just say to me, okay. Plus, what is the value of A1? The triangle, upper triangle, it will be 1 by 2 into the height is WL by 2 EI into the length is L by 2. Is it correct what I have written? Of WL by 2 EI into L by 2. And the positive direction, I mean positive. So 1 by EI I can take it outside, and when I write it, it will be WL square by 4 plus WL square by 8. So final answer what you are getting?
3
3 by 8 WL square by EI.
Yeah, WL square by EI. And the direction is?
Positive, anti-clockwise.
Yes,
upward.
anti-clockwise. Yeah. No, direction for slope, like you can say like it's anti-clockwise or clockwise.
Yes.
Yeah, here you meant like the deep beam is deflecting towards the up direction. Yeah. Yeah, this is clear, right? How we are calculated theta b. So in similar line, can you calculate yb? Since ya is 0, I have denoted it Okay, I will write it explicitly. YB minus YA is equals to 1 by EI. I am taking it outside since EI is constant. Okay, and you have to find out what is A1 into X1 bar plus A2 into X2 bar. Okay, where X1 and X2 are the centroids of the areas A1 and A2. So if I'm writing A1 will be a triangle, right? So it will be WL square by 8 into what will be the value of X1 from here.
Sir,
Yeah,
uh, how we are taking EI common because it is embedded in A1.
yeah, it is embedded in A1. Like I have written WL square by 8 alone, right? So I have taken EI cons outside.
Sir, for the deflection at B, is the answer 5 by 24 WL cube by EI?
5 by 24, no. Should be 5 by 48. So one person has asked the question, right? Like how you are taking EI as constant. See here I have taken EI as constant. Okay, and then I'm just taking what will be the area of the bending moment alone. That
Yes.
is same, right? When EI is not changing, how can I write it the same formula? I can write it as 1 by EI into area of the moment, bending moment diagram, A1 plus A2.
Yes, sir.
Okay? Yeah. If the bending, I mean, if the M by EI is not constant, then I have to go for the area M by EI explicitly. Okay, or separately. Okay. Now, what will be the value of X1? That is very important.
L by 4 into area of that rectangle into plus L by 3 into area of that triangle.
Yes, L by 3 into area of the triangle. Since here, from here I am measuring what is the length. Okay. So the centroid will lie here. Okay. And this length will be what? L by 3. And how you are getting L by 3?
Sir, that is half of मतलब L by 2 का 2 by 3.
Yes, 2 by 3 of L by 2. This is X1, which will be L by 3. Is it fine? Since, see, here 1/3 of the, I mean 2/3 of this length, the length we have actually taken is, the total length is L by 2. Okay. So 2/3 of this length will be L by 3. So I have to write here as L by 3. Okay. And the origin point is point B. Understood now, everyone?
Yes, sir.
Yeah. And what will be A2? Here we have already write it will be W. Excuse me. WL square by 4 into what will be the length? I mean X bar.
L by 4.
Yeah, L by 4. It should be 1 by 2 of L by 2. Okay. And when you are simplifying this, you will be getting 5 by 48 WL cube divided by EI. Is everyone getting this answer?
Yes, sir.
Okay. Yeah. And the deflection is towards the upward direction. Okay.
सर कैंटिलीवर बीम पे यूनिफॉर्म लोडिंग वाला एक एग्जांपल कराएं.
कैंटिलीवर बीम पे यूनिफॉर्म लोडिंग. ओहो.
या सर अभी मैंने टेस्ट सीरीज किया था सर, उसमें सब क्वेश्चन आया था. वो
Okay.
मतलब बहुत टाइम लग गया था, फिर छोड़ दिया था.
Okay, we will see all those things. Yeah. See, for example, for cantilever beam of a uniform loading, right? You asked, right?
Yes.
See, I will tell you what's the difficulty by using moment area method. Okay, you can do actually, but there is some calculation. I mean, the calculation will be somewhat difficult because you have to calculate the centroid of the parabola as well as the area of the parabola. Okay.
Sir, because composite beam was given, one was having 2 EI and another was having EI, so
Okay.
the moment area method was the only option.
Okay, fine. Yeah. See, for example, I think you are saying the cantilever beam might be something like this. This is, I'm taking this as 2 EI, okay? And this I'm taking it as EI.
Yes, sir.
And the load I am giving it something like this, and then this is point A, this is 2 EI,
On
and
full,
this
on
is
full,
EI. Okay,
sir.
yeah, full. You want fully? Okay, okay, then. Okay, like this you want?
Yes, sir.
Okay then. And then maybe I will say this as point B and this as point C. Okay. So what we have to do here is like first, what is the procedure here for moment area method? First, you have to draw the bending moment diagram. Okay. So if you draw the bending moment diagram, what this will look like? Can anyone draw the
Parabola.
parabola? So first, here I am drawing the bending moment diagram, and it will be positive or negative.
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 And the value at the here is what? At point A, the reaction, moment reaction. Let's say this is W. Anyone? What is the moment reaction at point A?
WL square by 2.
Yeah, WL square by 2. And here I will be having a parabola like whether it's an increasing slope I should draw or a decreasing slope I should draw.
So decreasing.
Decreasing slope, yeah. These things, how to decide whether I should draw with increasing slope or decreasing slope? Yeah, how we can decide whether it should be drawn with an increasing slope or decreasing slope?
Oh, intensity of
Shear
loading.
force. Yeah, intensity of shear force. You should take the intensity of shear force, like whether shear force decreases means the slope of the bending moment diagram also decreases. Okay, so in order to decide that, first you have to draw the shear force diagram, and then you can say like the the slope of the bending moment decreases all through its length. Okay,
Okay.
yeah. So in order to calculate what is the area of this, let's say this area is A1. Okay, in order to find out the area of this, then I need to know the area of the parabola, right?
Yes, sir.
Yeah,
So,
due to these things only, you won't be getting questions regarding all these things in GATE, especially because what is the difficulty, I will say. Okay, in GATE you won't be having questions like this, but whereas in test series, like test series from coaching institutes, you will be getting lot of questions with respect to these. Okay, so here I am drawing a parabola like this, I mean a curve like this. Okay, this is 1, this is 2. Okay, and this curve I am naming this as y is equals to x square. Okay, and this length is d, and this length is b. Okay, and if I want to find out the area of 1, then the formula is like this:
method
a1
of
will be
BH.
bd by 3. Okay,
Yes, sir.
yeah, and the area of 2 is 2 by
2 by
3. Yeah, 2 by 3 bd. And if I want to calculate the centroid, then I'm taking the centroid from this position. Okay, from this position, the centroid is x1. Okay, x1 will be equal to b by 4, and x2 will be equal to, I'm putting centroid, so x2 bar, x2 will be equal to 5 by 8b. So you have to remember all these things, right? You have to remember this formula, you have to remember this formula and this formula. So basically in GATE you won't be getting questions based on memory. Okay, so I don't think like in GATE like they have asked questions like this also, to my knowledge I'm saying. Okay, if you have found any questions, like you can say me whether you have found any questions in the GATE previous years question papers.
नो सर, इतना डिफिकल्टी लेवल का नहीं था सर.
Yeah, actually, it's not very much difficult, but like calculation, it will take some time, and also you have to remember these formulas separately. So only they don't ask questions in gate. Whereas in test series by coaching institutes, they will ask questions so that you get trained up for the most difficult level questions. Okay. So for this, if you want to find out the area, which area I have to use?
One.
Sir, here these formulas are
Yeah.
standard.
This, what? This formula?
Are standard for that parabola and that shape.
Yes. This formula is standard for these kinds of parabolas. Okay, with B, D dimensions. Only thing is like whether based on the type of curve you have to design. Whether you have to see based on this. This is one region, right? Actually, this is similar to one region. And if you are getting a parabola which is similar to this kind of region, then you have to use type 2. Okay.
Yes, sir. And in left hand side diagram, SFD will be rectangle positive.
SFT, I don't think it will be rectangle. It should be like a triangle, I think so. With see,
Yes, sir.
yeah, it should be triangle because the load intensity actually is constant, so the slope should be constant. If the SFD is a triangle, right, then you will be having a slope as a 0. So it should be a rectangle. A triangle with constant slope. Either it should be like this or it should be like this. Okay,
In
we will.
case of rectangle, it will represent zero intensity.
Yeah, in place of rectangle, it will represent zero intensity. Like point loads.
Yes.
Okay.
Sir, can you tell me a case where
Yeah.
the मतलब पैराबोलिक हो पर इंक्रीजिंग प्रोफाइल में हो BMD?
BMD increasing profile. What shall I do?
I think it was uniformly varying load where intensity was zero at fixed end and it was varying at outside end. Was that?
Yeah, something like that. And like you, one person has asked with increasing slope, right? So if I have to draw the parabola with increasing slope means, then it should be something like this. Okay. But you haven't seen BMD like this. Like you can refer to my older videos, right, where I have extensively taught about bending moment diagrams, right?
Okay, sir. Okay.
Yeah, if you see those lectures now, you can get. We have discussed a lot of parabolas like with increasing slopes, decreasing slopes, and we have extensively seen about CFO's diagrams also, right? Is that fine?
Yes, sir.
Yeah. Now coming back to this problem, okay? So here, since this EI value is actually changing from this length to this length, let's say this length as L by 2 and this length as L by 2, okay? Then what I should do, I have to draw this diagram again, okay? So if I draw this diagram again, it will be like, again it will be a parabola, okay? Only thing is like you will be getting two times. Like for example, this will be WL square by 2 divided by 2 EI. Okay, it will become WL square divided by 4 EI. Okay, and at this point you will be having WL square. You need to find out what is the bending moment at this point by using the bending moment equation. Okay, you have to find out the bending moment equation all through this length. Okay, and then you have to put the bending moment value at x is equals to L by 2. Okay, at that point you will be having some value. Maybe here we can assume it as WL square by 2. Okay, then you have to divide
Excuse me,
this.
sir.
Yeah.
Can you repeat this last part?
Okay, see, first I have calculated the I have drawn the bending moment diagram, right?
Yes.
Yeah, then what I should do is like up to this length of L by 2, Okay, the moment, I mean, the area moment of inertia is, or the total product of EI, it is like 2 times of EI. Okay, so what I have done at this corner is like I have divided the moment by 2 times of EI. Okay, so what I have got is like WL square by 4 EI as the answer. Okay, and this actually varies all through this, and then from point C it is like EI only. So at point C I have to calculate what is the bending moment value. That can be calculated only when I know what is the variation of this bending moment all through this length of the beam.
Sir, yes, sir. From approaching left hand side to C, this M by EI value will be WL square by 16 EI.
Oh, at point B, at point C you are saying?
Yes, sir. From approaching from left and from approaching from right, it will be WL square by 8 EI.
Yes, yeah. So you will be having a step like this, right?
Yes, sir.
Okay.
Sir, how this is happening? I am not getting.
Okay, see. First, you have to find out what is the bending moment at this section. Okay, for like at each cross section, you have to find out what is the bending moment equation. So, can you please find out what is the bending moment equation actually?
From right hand side, it will be WL by 2 into L by 4.
Okay, maybe I have to see for calculating the bending moment equation. You can simply ignore what is 2 EI and what is EI. You can actually take a beam like this. Okay, so I am taking a section like this, x, and then it will be W into X into acting at a distance of X by 2.
Sir,
So,
without calculating the whole equation, we can directly find it by जो left hand portion है उसका consider करके BC वाले portion को consider करके the moment can be found out.
no, but first I need to find out the bending moment equation, right? Once I know the bending moment equation, then I know what is the bending moment value at point C. From there,
Sir,
yeah.
sir, without calculating the bending moment equation, we can also find out the bending moment at C by simply उसको अलग करके BC वाले portion को.
Yeah, okay. You are saying like you are actually finding out what is W into L into L by 2, something like that, right?
Yes, sir. Yes, sir. W
Yes.
into L by 2 into
L
L by
by 2. Yeah. That also you can do. Yes. So if you are writing W into L will be the total load and it is acting at a distance of L by 2. That is the thing you are saying, right?
W into L by 2 into L by 4.
Yeah, W into L by 2 into L by 4, which will be
Yes.
WL square by 8. Yeah, that also you can do. But see, at this thing, for this thing you can actually do, because like it simply turns out to be since I'm calculating at point C, whereas in some other thing if you calculate the bending moment equation, it will be a lot more convenient. Okay,
Okay, sir.
yeah. And the another person who asked doubt, right, whether it is clear.
So bending moment at x will be W x square by 2.
Yeah, W x into x by 2, it will be W x square by 2. And here at x, what you will be putting, it will be L by 2, right? Since I am taking from this direction.
Yes.
Yeah, so it will be W into L by 2 the whole square divided by 2. It will be WL square by 8, as another person pointed out. Okay, this is the bending moment at section C. Okay, so here if I divide this WL square by 8, here I have two moments. I mean, two at this junction I have two what to say, two cross sections, right? One is of 2 EI and another one is of EI. So what I have to do, I have to divide this both these sections. Okay, one is by 2 EI and another one is by EI. Okay, and one will be 16 EI. So this will be 16 EI and this will be 8 EI. So which is actually not, it should be not equal to, but here something like this, WL square divided by 8 EI. Up to this it is clear.
Yes, sir.
Yeah.
Sir, here
Yeah.
For A to C portion, we were calculating bending moment from left hand side, and for B to C, we are calculating from right hand side. Means,
Yes.
is it fine?
Yeah. See, this is, see, from A to C, I'm not calculating from the left hand side or from the right hand side. Here, what I'm doing is like I am actually taking the cantilever beam only without any change in the moment of inertia or the without any change in the Young's modulus value. See, this equation, this bending moment equation is valid for the whole beam, right?
Yes, sir. Means either we can use it from any side.
Yeah, any side. So here what I have done is like I have taken from the right hand side alone. Okay, so x value I should put from this side. Okay. See, this bending moment equation value is valid for all through the beam. Okay, but only only variation is like I should put the x value from this side. Whereas if I am taking from the left hand side, what it will turn out to be, I have to calculate the reaction and then I have to calculate a vertical reaction as well, moment reaction as well as vertical reaction. And then I have a uniformly distributed load also. So all these three things together, I have to take individual effects of all these moments and then I have to find out what is the bending moment reaction. What is the bending moment equation from the left hand side if I calculate.
So that will be complicated.
But yes, that will be complicated. So only I am taking from the right hand side.
Okay, sir. Understood.
Yeah, but the net effect will be same. Both these things will give the same same effect, but the equations will be somewhat complicated when I take it from the left hand side.
Yes.
Understood? Okay. So here we have actually calculated the M by EI diagram, right? So once we have calculated the M by EI diagram, then I can go for area splitting. Okay. Yes.
Yes, sir.
Yeah.
Yes, sir.
So here I could calculate this area as A1 and this area as A2 and this total area as A3 because this is a single parabola. And this actually corresponds to case number 1 where we have seen here. And this also corresponds to case number 1. And this is a rectangle. Okay, so directly if you want to find out what is the value of theta C or theta B, okay, where if I take what is the value of theta B, then I have to find out what is the value of A1 plus A2 plus A3. Means like I have to know this formula beforehand, okay, BD by 3 to calculate the areas of A2 and A3. Understood?
What, sir?
See, here I have split this area into A1, A2, A3. Okay, you have understood this splittage, right? Why I have taken
Yes.
this kind of splittage so that I can calculate this rectangle area separately. Then I can calculate this parabola area separately, and this A3 is like a single parabola. Okay, this total parabola.
Yes, sir.
Yeah. So from this I can calculate A2 area, A3 area separately and then I can calculate A1 area. When I sum all these areas, then I will get what will be the slope at theta B.
Yes, sir. And in this case,
Yes.
uh, the case num here on right hand side,
Hmm.
y is equal to x square given. So how we know that the situation is same for y is equal to x square?
Okay, see, that's a good question actually. See, for example, this what to say, this formula of area is valid only for y is equals to x square. But we have seen bending moment equations where y is equal, y is equal to x cube also, right? We have seen about cubic parabolas also, right?
Yes, sir.
Yeah. So when cubic parabola actually happens,
When uniformly varying loading.
okay, means like the shear force diagram should be a parabola.
Yes, sir.
Yes, but for example, in this case, the shear force diagram, it's actually a rectangle, triangle. Okay.
Linear.
Yeah, linearly varying. So only for these kinds of cases, like we are having the formula as A1 and A2. But if the parabola is something like y is equal to x cube, then this formula is not at all valid. Okay.
Okay, means from that uniformly distributed loading we are using this.
Yes, only for uniformly distributed loading we are actually getting, okay, I know the shear force is actually linearly varying, then the bending moment diagram is actually a second order parabola, then I can use all these formula like that.
And in this case, if
Yeah.
there was something some point load given, then we can't use this.
Yeah, with in addition to this you are asking, right?
Yes, sir.
In addition to this, if they have given some point load, then definitely the bending moment value, it actually changes, right? It will be something like, for example, if they are giving one point load, then you have to consider that moment also into consideration. Okay, as long as the bending moment diagram is of second order parabola, then you can use this. That's the theme I am saying, or that's the concept.
Means for that case, this is not applicable.
Yes, see, even for example, even you have point load, and if the bending moment is something like a second order parabola, like this, okay, this is the bending moment value you are getting. I mean, this is the bending moment diagram which you are getting all through the length of the beam. You are having a step here, means like you are having some concentrated moment here. Then also this thing is valid because this is a second order parabola.
For concentrated movement.
Yes, for concentrated moment. But if you are having for concentrated load, then if the what I'm saying is like, as long as the bending moment diagram, okay, if it has second order parabola, then you can actually use this area formulas. That's the thing I'm saying here.
And from whenever this second order parabola is not there, then we can't use this.
Yes, then you can't use this.
Okay, sir.
And this, if you are having some third order parabola, which is like y is equal to x cube, then you can't use here.
Yes.
Okay.
Yes, sir.
Yeah. So one person has asked this question, right? Is it clear how we want to proceed?
Yes, sir.
Yes, sir.
Yeah.
Thank you, sir.
Yeah. And if x1 is always calculated from here, but origin point you are choosing from here only, right? So this length is actually x1 bar. This you should also note down.
Sir, that x1 bar you have written b by 4, it is from left hand side?
Yeah, it is from the left hand side. It is from this. Maybe you can name this as the base. From this I am taking. Okay.
सर
Yeah.
समझ में नहीं आया, x1 बार कहाँ से है, लेफ्ट हैंड साइड से राइट हैंड साइड से?
See, x1 bar is from the see, actually what you have to find out the distance of the centroid from the origin point. Okay, for here you are interested to calculate what is the value of theta b, means I have to take the centroid from the origin point. Here the origin point I will fix it as point b only, right?
Sir, that thing is clear. I want to ask the right topmost portion.
Right
that,
topmost. Yeah.
Yeah, that you have described that x1 bar equal to b by 4.
Yes.
From left hand side or right hand side?
From left hand side. From left hand side.
Okay, sir.
Yeah, but so here what happens is like, I only know the distance from here. From left hand side only I know.
Okay, sir. Okay, sir.
But I have to calculate this distance. How I will calculate? I will divide the, I mean, take the difference of total length minus x1. Then I will get the original x1 bar. For this,
Okay.
For this problem I am saying, okay. Whereas
Okay,
here I have denoted x1 bar, like, because for this problem, like, I have to find out the centroid. So this is the centroid. Maybe I will explain it further, okay? In the new slide I will explain.
Clear हो गया, sir?
Clear?
Yes, sir.
Yeah, to everyone it is clear, right, what I said now? If you have any doubts, you can ask me. Is everyone clear? Or you have any doubts, please ask me.
Sir, expression for x2 bar.
Expression for x2 bar. No, actually here only x1 bar is applicable. So x2 bar we are not going to use for this problem because I don't have this type of a parabola.
It is also from left hand side, no?
Yes, it is also from left hand side only. X2 bar is also from left hand side. Means you will be having somewhere here the origin. I mean the centroid. Okay, so this will be X2 bar. Understanding, right? If you have any doubts, like please let me know.
Yes, sir. That centroid point to reference point.
Yes.
That centroid point to origin point is the X2 bar.
Yes, that's the thing I want to say. See, what I have mentioned in this problem is, I mean, in this figure is like, this is like a generalized case I have given. Okay, in order to say what is the difference, because I only have the formula for b by 4 and 5 by 8 b, which actually denotes x1 and x2 from this left hand side. Okay, x1 is calculated from here and x2 is also calculated from here. Okay, but whereas for my m by ei diagram, okay, I have the point b here, okay, and I have parabola like this, and I know x1 length, I mean I only know the x1 length, which is equals to b by 4. For example, let's say this total length as l by 2. Okay, then if I write b by 4 means it will be l by 4, right? So x1 will be l by 4, but I want distance, this distance, to calculate the centroid, and and the distance of centroid will be taken from the origin point, right? So this if this is the origin point, because this is the origin point, means I have to find out the slope at point B. Okay, so I have to find out this, so it will be L by 2 minus L by 4, which will be L by 4.
Slope or deflection?
Yeah, slope or deflection, anything. I mean, only for
So,
deflection I need the centroid. Okay, for slope I don't need the centroid. Only for
yes.
deflection I need the centroid. Yeah. Okay.
Yes, sir.
Is it clear,
Yes,
right?
sir.
No issue?
Right.
Yeah. Okay then. So, shall we proceed to the problems? Like, shall we work out some problems on moment area method?
Yes, sir.
Yeah. So, up to now, all the procedure with respect to moment area method is clear, right?
Yes, sir.
Okay.
One question, sir.
Yeah.
Here, reference point was located on left hand side, so we are considering moment from means area from left side. If reference point is located at right hand side, so we will consider area and its moment from right hand side.
Okay. See, that depends on where you are actually taking the. Yeah. No, can you repeat the question again?
My if my reference point is at left hand side, then whatever
Reference
force.
point. See, reference point means the point where slope or deflection is 0. Okay.
Yes, sir.
Yeah. So maybe here we are having the reference point. Okay. Now you say. Yeah.
So in this
Mm.
case, we are considering area and its moment from
Mm-hmm.
left hand side diagram.
Yes. Yes.
And then if I choose the reference point at right hand side, then I will take area and moment from right hand side.
No. See, reference point is actually different. Okay. Origin point is different. So only from origin point you are actually calculating what is x bar. I mean all the centroids and what is the moment of area of that centroid. Okay.
Yes, means I am seeing
Mm-hmm.
for any another given question.
Yes.
If originate is at middle and if I am having my reference point at right hand side,
Right hand side.
then
Yeah.
in that case I will take area and its moment from right hand side.
Yes. 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 Yes.
Okay.
Okay. For example, you are saying like this is the reference point I am having, and this is the origin point I am having. Okay. And
Yes.
if I have the diagram something like this, and here also I have to take only from here, and then in this case directly I can write this same formula b by 4.
Yes, sir.
Okay. Fine.
Yes,
But
sir.
yeah, but the sign I won't be changing. For example, if here in this case origin is here, okay, but towards this direction I am taking, you don't take it as minus L by 4. Okay, it is actually plus L by 4. Only the distance I need, not the signed distance. And here also, let's say this is L by 2, and here also x1 turns out to be b by 4, which will be like L by 2 of it will be L by 8, right? So x1 should be positive, like only the distance I need, not the signed distance.
Yes.
Okay. Yeah. So shall we do some problems?
Yes, sir.
Okay.
Yes, sir.
Yeah. So since you have since lot of things have been discussed, now I will give some little bit complicated problem. Not with respect to parabolas. Okay, parabolas definitely. I mean, most probably they won't ask in gate exam because you have to remember the formulae. So mostly they won't ask. Okay, but anyway, it is safe to learn, right?
It is safe to.
It is safe to learn, so that like if they ask, then we should be in a position to solve that problem.
Yes, sir.
Yeah, this moment is 2WL. Okay, and this length is L. This is point A, and you have to calculate what is theta c and what is yc. So can you first draw the bending moment diagram?
Value of load P.
Value of
Load at C P.
okay, yeah, this is W. So can you draw the bending moment diagram? And here bending moment diagram and M by EI diagram is same, since EI is constant throughout. Okay.
Sir, can we bifurcate this problem into two of
Mm,
individual, one having the concentrated moment and another having the simply load?
yeah, that also you can do. Yes. See, for example, you are saying like you are saying like you are having a moment like this, and then plus this, right? This is the thing you are saying.
Yes, sir. Yes, sir.
Yeah, like this you can do. Only thing is like again you have to find out what is yc due to load acting at point B or moment acting at point B.
Yes, sir.
Okay, and then you have to find out, first you have to find out what is yb, then what is theta b, and then you have to I mean, and then like no actually this
Load
also, huh?
directly C can be calculated.
How can you find theta c from this? Theta c or yc for this first case alone. Let's say this as the first case and this as the second case. Second case, you can easily find out what is yc or theta c. Doesn't matter. Like let's come to first case, okay? And here you are having a concentrated moment. So basic formulas I know only is like when I have concentrated moment at for a cantilever beam, let's say like this. And what is the slope and deflection for this? ml square by
MN by.
ml square by
2EI or 8EI?
yeah. Okay, let's imagine, since I don't have the formula sheet. Okay, I'm
ML by EI
okay.
for theta and ML square by 2 EI for deflection.
ml by EI and ml square by 2 EI. Okay, so this value is actually valid only when moment is acting like this. Okay, so here what I have is like, first I need to draw the bending moment diagram to see if there, like for example in the last class I have discussed, right? The bending moment diagram should look something like this from B to C. From B to C, I should not have any bending moment. Only then I can actually use YB equals to theta B into what to say. I mean YC equals to theta C into YB, I think so.
YC is equal to theta B into
Theta B into YB plus YC, something like this, right? Last time we have discussed, right?
yes.
Yeah, so only during this where moment is actually zero, only at that thing you can actually use this formula, because at that point there exists like straight deflection. The deflection curve would be a straight line. Whereas here, if you draw the bending moment, whether you are getting a straight line deflection from B to C, let's draw the bending moment diagram, okay? So 2 into WL is the whole loading. So what I will be getting is like 2WL, it is in this direction, so it will be in this direction. So if I draw the moment, it will be left clockwise. So I will be getting like this, yeah. So here in this case, it is valid. You can actually use it. Left, it is anti-clockwise, so it's negative, and it will be 2WL. You are getting what I'm saying? Hello? Hello?
Yes, sir.
Yes,
Yeah,
sir.
one person has asked this doubt, right? Whether he got. Yeah, so what I should do is like first I should find out what is theta b by putting L is equals to L by 2. Okay. And then I have to find out what is YB. And then I have to find out what is YC, which is equals to YB plus theta. I mean, this deflection. I mean, YB plus theta B into L, this length L by 2. And then I have to find out the this is for the first case, and then I have to find out YC for the second case, and then I have to find out the total uh, the asked question.
Sir, I am getting theta c for the
Hmm.
combined 1 and 2 as
Okay.
minus W L square by 2 EI.
Minus,
WL square by 2 EI.
yes, that is correct. Yeah, that is the answer. Which method you used? Moment area method you used, or like the right side method you used?
सर सेपरेट करके मोमेंट एरिया मेथड यूज किया है.
Oh, separate method, and you have used moment area.
Yes, sir.
Okay, that also you can do. Yeah. So you have done like you have done separately, like you have drawn moment area for this separately, and then you have drawn moment area for this separately.
Yes, sir.
Fine. But see, in this single thing itself, you can also draw. Okay, since like bending moment diagram, like we can easily draw, right, for this kind of problems.
Yes, sir. Yes, sir.
Yeah. Okay. So I'm erasing all these things. So please check whether you are getting all these, do different kinds of methods, and see to that like you can validate all the answers, okay, by using different methods.
Yes, sir.
Yeah.
Thank you, sir.
Okay. So can you say what is the bending moment diagram for this loading looks like? Or directly can I draw the bending moment diagram?
टू राइट एंगल ट्राइंगल्स टाइप है कुछ.
Okay, two right angle triangles. Okay, one, I think one will be a trapezium and another one be a triangle, right?
हाँ सर. यस सर. यस सर.
Okay. Yeah. Like this, are you getting? And this length will be WL, and this will be 3WL by 2, and this
Yes.
will be WL by 2. Okay.
Yes, sir.
Yeah. So here, what I should find, theta c I should find, and yc I should find. So what will be the origin? C will be the origin, and reference point, I mean, and the reference point will be A. Okay. So theta c minus theta a will be equal to area of a1 plus a2 plus a3, which will be nothing but, since theta a is equals to 0, so theta c minus 0 equals to a1. So this will be a1, this will be a2, this will be a3, and these things are negative. Okay, so with sign I have to take, and this is positive. So if I write, what will be, I am taking 1 by ei as common. Okay, and what is a1 actually? It is minus wl into l by 2. If I do any mistake, please let me know. Okay, and a2 is minus wl square by 8, and a3 is the upper triangle. Okay, so wl square by 8. Is this correct, what I have written? I am simply finding out the areas alone.
Sir, can you tell me the answer of YC?
YC
Minus
WL cube,
7.
yeah, minus 5 WL cube by 12 EI.
Minus 5 or minus 7?
Minus 5.
Okay, sir.
Okay. Others are following, everyone?
Yes, sir.
Yes, sir.
Okay. So if you have any doubt, or if you want me to draw, do the calculations also, please let me know. Okay. So it will be, yeah, clockwise direction. So theta c, whether everyone is getting this answer, WL square by 2 EI.
Sir, it will be minus.
Yes,
हाँ
sir.
sir,
Yeah,
clockwise सही है.
yeah, clockwise. Yeah. So shall I do YC? Everyone got theta c?
Yeah.
Yes, sir.
Okay, thank you. So YC will be 1 by EI into A1 x1 bar. Okay, so A1 is minus WL into L by 2 into what is x1 bar. From here I have to calculate. So L by 2 plus L by 4. So it should be L by 2 plus L by 4. Three L by 4. Okay, and what is A2? It is minus WL square by 8 into x2 is here. Okay, it is 2L by 3, and WL square, I'm rubbing this off, WL square by 8, okay, into x1 is L by 3. Is this fine, what I have written? All x1 bars are fine?
No, sir. X2 bar
Okay,
from C origin 2L by 3 plus L by 2.
x2 you are saying. Okay, L by 2 plus uh, here L by 3. Okay, so it should be
Okay,
2L,
sir.
2L by 3. Fine, right?
Okay, okay.
Yeah. Up to this, everything is correct what I have done. So next step, if I am writing all the WL cube, I am taking it common. Okay, it will be 1 by 24 minus 3 by 8 minus 1 by 12, which will be 5WL cube divided by 12EI. Direction is downwards. YC. Is everyone getting the answer?
Yes, sir.
Yes, sir.
Okay. So shall I proceed to the next problem?
Sure, sir.
Okay. So now we will work out problem based on like difference in EI. Okay. We will work out a problem with difference in EI. So I have a beam like this. Then I have this is 2EI. Length is L by 2. This length is L by 2. This is EI. And I have a load like this. This is point C, point B, point A. Okay. So you have to find out what is theta C and what is YC. So can you please say what will be the bending moment diagram for this beam will look like?
Triangle.
Triangle, yes. And what is the bending moment at point A?
PL.
PL. So whether it should be upward triangle or downward triangle? Negative, na?
Downward.
Yeah,
Down, negative.
negative. P into L. Okay. Now this is the bending moment diagram. Okay. A, B, C. And what will be the bending moment value at point B?
PL by 4EI from left hand side.
And that's fine. Since I'm here, I'm not considering EI. Can you say?
PL, only PL by 2.
Yeah. Since it's like straight line, we can actually divide. Okay. PL by 2. Now I am drawing the M by EI diagram. Okay. Yeah. So at point A, if I what I should do, PL by 2EI. Okay. If I do the M by EI. So it should be PL by 2EI. 1 minute. I am writing it a little bit up. Okay. Then if I consider from the left hand side, see this is the point B. Okay. Here I have 2EI at this junction and here I have EI at this. Excuse me. So I have 2EI from this junction and I have on the right hand side EI. So at point B, 2 times I have to calculate M by EI. Okay. So first what I will be doing is like PL by 2 into 2EI. So it will become PL by 4EI when I take it from the left hand side, as one person pointed out. Okay. PL by 4EI. Yeah.
Is the 16 PL square by EI?
16?
5 by 16?
Yeah, 5 by 16 PL square by EI. That is the slope value.
Theta C, yes.
Yeah. Okay. So this will be a straight line with PL by 4EI. And again, when I calculate at point B, PL by 2EI, when I am taking from the right side cross section. Okay. So these two values I have to put it here. So one is this what will be this value? Whether it will be PL by 2EI or PL by 4EI.
PL by 4EI.
Yeah. PL by 4EI. If anyone did not understand, please let me know. Okay. And again here I will have PL by 2EI. Okay. And this will be again a straight line. And this is point C. Okay. Yeah. So now I have to calculate what is theta C and what is YC. So theta C minus theta A. Okay. Theta A is 0. Okay. Is A1 plus A2 plus A3. Okay, this I am taking it as 1, this I am taking it as 2, this I am taking it as 3. Okay, so A1 plus A2 plus A3 gives me the value of theta c. So when I write A1 is actually a triangle. Okay, so it will be half into the base is L by 2 and the height is PL by 2EI. This is A1 plus A2. A2 is a rectangle, right? PL by 4EI into L by 2. And A3 is again 1 by 2 into the length is PL by 4EI, I think. 4EI into L by 2. Okay?
Yes, sir. Sir, is YC equal to PL cube by 8EI?
PL cube by?
EI?
No.
Okay, sir. Finding again.
Yeah, it should be 3 by 16 PL cube by EI.
Okay.
Yeah. So when I simplify this, I will be getting 5 by 16 W. Oh, I have one mistake I have did here. Did anyone noted it when I'm writing the areas?
Area of triangle.
No.
Okay.
Negative sign I haven't given.
Hmm.
Hmm? So be careful with the sign also, okay? So it should be minus 5 by 16 W L square by EI. Is everyone getting this answer? Okay. Is everyone getting this answer or not?
Yes, sir.
Yeah. What about others?
Finding, sir.
Okay. Should I wait or can I proceed for YC?
Proceed for YC, sir.
Okay. Now I have calculated A1, A2, A3 separately. Now what I will do is like I will calculate X1, X2, X3 separately. Okay. X1 should be uh, 2 by 3 times of L by 2. Okay. So it should be L by 3. And X2 should be like L by 2 plus L by 4, right? It should be 3L by 4. And X3 should be L by 2 plus 2 by 3 times of L by 2. And X3 should be, when I write this L by 3 plus L by 2 again, it will be 5L by 6. And when I write A1 X1 bar, well, A1 is actually minus PL square divided by 8EI into L X1 bar is L by 3. Then X2 bar is minus PL square by again 8EI, and here X2 is 3L by 4, and X3 is minus PL square by here 2, 4, 8, 16, 16EI into 5L by 6. So on simplifying this, everyone should get the answer as 3 by 16 PL cube by EI. Direction is downwards.
Yes, sir. We are getting.
Okay. So this change in EI value, everything is clear, right?
Yes.
Okay. So now everyone is confident about how to proceed with moment area method, everything.
Yes, sir.
Okay. So in this week, maybe by Tuesday, okay, by Tuesday I will be uploading some questions on deflection of beams. Okay, till now what we have worked on, I will be uploading some questions and as homework questions. Okay, and please
Okay,
do.
sir.
Yeah,
And it would be better, like the chances of the chances of probability to be this kind of problem in gate,
yes,
like
yes,
if you
yes,
some.
yes. That's what. Like similar problems only, I will be asking in the homework problems also. I won't be
And
asking like cubic parabolas or something like that. Okay.
okay, and it would be better if you could give us from the total like sum problem or like that,
What? What? What?
from total sum top.
Oh, like including every chapters you need.
Yes, sir.
Okay. Okay, that also I will try. Yeah. But as of in today's week, I will be uploading deflection of beams. Okay. Yeah.
Sir.
Okay. Maximum by Tuesday I will upload because today I'm at home. So tomorrow I will be going to my hostel and then I will upload. Okay.
No problem, sir.
Yeah.
Thank you, sir. Thank you. Thank you.
So can we stop for today's class? And a lot of things are pending, and I don't know how we will be completing all those things. And still, I think we have 2 more weeks only to complete the syllabus. Okay, so we will be having some extra classes also, if you wish.
Uh, and one more thing I would like to tell you, those covered which have those topic which have not been covered. So
Okay.
if you kindly make some questions regarding this topic and give us as an homework.
Okay, see, concepts I will cover. Okay, concepts I'm covering, but still some more concepts. Like as I said today, I planned for completing Castigliano's theorem also. Okay, but I couldn't complete Castigliano's theorem. And before Castigliano's theorem, I have to give you some intro on strain energy.
Strain
Yeah,
energy.
so only then Castigliano's theorem will be somewhat felt complete. Okay.
Okay.
So okay, maybe in next class we will take up to 9 o'clock the class. Okay.
Okay. Thank you, sir.
Yeah. So shall we wind up the class
Yes,
today?
yes, sir.
Yeah.
So conjugated beam method,
Which method?
conjugated beam method, sir.
No, those methods and all we won't be seeing. Mostly this moment area method, this Castigliano's theorem, and basics of this, like how we are based on logic, how we are actually going to find the deflection. These things is more than enough, I think so, for gate.
A double integration method and this method.
Yeah, double integration method and all, like it's not needed. See, double integration method is something like, for example, you are finding out the deflection equation, right? Bending moment equation at x6 for a beam. Yeah. And after that, you have to find out what is the m by ei, which is equals to 1 by rho, which is equals to d square y by dx square. Okay. So you need to find out what is y of x. So if you integrate this twice, you will find out what is y of x. And for integration, you are having some constants like a, b, c, and these constants can be found out based on the boundary conditions. For example, at a, like theta a equals to 0, y a equals to 0, if you substitute, then you will be, means like, for example, dy by dx is actually theta. Okay. So for cantilever beam at a, theta a equals to 0 means dy by dx at a equals to 0. So based on these things, you can find out the constants and you can write it. Okay. So that is actually double integration method, and that also we won't be seeing. Okay.
Okay, sir.
Yeah, if you see, based on all the gate previous year's problems, based on all like moment area method and this Castigliano's theorem, and the basic manipulation of the standard formulas, like you can easily solve all the questions. Okay.
Sir,
Yeah.
there was one question in previous year. They have given it was from stress strain. So they have given one element and its loading condition means sigma x for that, and they tilted that element and then they ask for values.
Oh,
I
oh.
don't remember that question.
Okay.
So
So
means
can
for
okay, can you please forward? Can you please mail me the question so that I will take a look into it?
yes sir.
Yeah.
Okay.
Okay. So can I stop here?
Okay, sir.
Yeah, I will upload. Yeah, I will upload the recording today. Okay, or by tomorrow.
Okay, sir. Thank you, sir.
Thank you.